Hey guys, this is Basketball here, and I'm going to be live solving yet again another math competition. This time it's called WOCOMAL, the Worcester County Mathematics League. So I already did meet one. I didn't upload it. I'll upload it eventually. But I'm gonna be doing meet two this time, which has completely different categories. These are the meet one categories. These are the meet two categories. So we're gonna be mocking these. Problems. I have no idea what these are, as always. But one difference is if you saw my Rhode Island Mathematics League video, you have seen that I use a timer on my phone, because each round is 10 minutes, and it's actually the same for this competition. But instead, because I'm on my computer, which I turned into a tablet, things are going to be a little different this time. Instead of a timer, I'm going to be using a stopwatch because again, I don't write at the same pace on this computer slash tablet, so really it's gonna be how fast can I complete the problems? And again, if it's like 12 minutes, I'm not gonna like discredit it or anything. I'm doing this for fun. I'm seeing if I can get all the problems right, hopefully. Because yeah, I've never gotten every single one right. I've gotten like within a few wrong. Rhode Island Mathematics League spoiler, I got let's just say less than 2 wrong on the whole thing. But yeah, so we're gonna get right into it. I again had no idea what these problems are gonna be like. I'm gonna put on the stopwatch this time. So we have 5 rounds. What I have decided to do is count the last 3 because if I were to actually take this meet, those would be the 3 that I would actually do. Um, in the team round, I'm just gonna count and hopefully we can get that within 25 minutes in team round. But yeah, let's just get right into it. So this is the sheet. This is the coach's copy, but we're gonna zoom it out so we can see. So ready? I know the answers are on the next page. I think I don't want to. Is it say answers? Yep. Okay. I'm not gonna go. I'm gonna go right after this. 3, 2, 1, and go. Okay. I gotta go out more. An item for sale is marked up 25%, reduced by 50, and then later reduced by 40. So what percentage is the current sales price? I'm gonna try my phone. It's gonna distract me. So let's just call the item $100 just for what that loss of journality. Also, I'm gonna be posting this PDF on the YouTube video because I remember last time I did it on paper and I had to upload that, but at least you can see like my work. So $100 goes to 125, reduced by 50. So that means it's gonna go to 125 halves. Then later reduce another 40, so that's 3/5 of whatever it is. 125 halves. So this is 125. You get what? 75 halves again? Oh wait, no, not again. 75 halves. So what percent of the original sales price is the current? Oh, of the original. Okay, wait. So 75 halves x equals 100. So we get 200 over 75? Huh? So divide by 5, you get 40 over 15. Divide by 5 again. You get 8 over 3. So that would be 2 2/3. So that's like 2. Am I allowed to do it as a, it would be 266.6 repeating percent, I think. Or what if we do, let's just do X, like why not? Item is X. So it becomes 1.25x. Or actually, I have a better idea. Just cross it out. X times, if it's marked up 25, it's 1.25. Then it's going to be reduced by 50, so I'm keeping 50 of it, so multiply that by 0.5. And reduced by another 40, so I'm multiplying by 0.6. All we know is this is going to be 0.3. So we should get 0.375. So 0.375x. Oh, so maybe I did do something wrong. So 37.5%. I guess that's the answer. Good thing this is not counting. I hate arithmetic. Okay, number 2, simplify. It's really just 2 times everything, because we're dividing. So 2, oh shoot, okay. The denominators don't look that nice, actually. Well, it's really 2 times everything, so it's 5/9, 4/9. That would be 1/8 plus 1/2. So what would be the least common? 30, no. 2 cubed, 3 squared, so it'd have to actually be the product, so it'd be over 72. So multiply by 36 here, multiply by 9, multiply by 8, multiply by 8. So what do we get here? Over 72. We get something. So that's actually 1. Yeah, 1, 72, 81, 107 over 72. Oh, no, wait. It's 117, 117. Or then it's 26 at first. 117 over 72. Now, they're both divisible by 9 because the sum of the digits of 117 is a factor of 9. So that's 13 over 8. Yeah, 13 over 8. If that's not right, I don't know what to say. The 3-pointer? Ooh. So this is just geometry. Or it's really common sense geometry, really. I don't know, I'm just trying to make a... I don't really care about spacing. I haven't even really read the fractions yet. Let's just check the timer so far, actually, just to see where we're at. 5 minutes. Okay, we're fine. AB is 1/5 of BD. BC is 3/5 AC. I'm noticing. Oh, maybe it's multiples of 6. Let's just. I have an idea. We'll just call this X. So then BD is 5X. BC is 3/5 AC. So BC. So wait. BC is 3/5 of AC. So BC over AC is 3 over 5. So this should be 3. Wait. If that's X, so then it's something in the form KX over AC, which is X K plus 1, which is 3/5. So 5KX equals 3KX plus 3X. And we can cancel out the X here. And we get 2K is 3, K is 3/2. So this should be 3/2 X. Right? And that makes sense. BC is 3/2 X. 3/5 AC. So wait, let's just actually check. 3/2 X equals 3/5 of AC, which would then be 5/2 X. Yeah, good. Okay. So that would be 3/2. But then you know BD is 5X, and you know part of it's 3/2, and 5 is 10/2, so this is 7/2 X. And we want to find CD over AD. Okay. So 7/2 X over 80. So it's 7 over 2 times 1 over 6, 7/12. Come on. I want to find my error in the first one. Just so I can confirm it is 37.5. Or whatever it was. Because I remember there was a percent one like this in Rimmel and I got it wrong. That was the only one that I got wrong in the meet. 100 to 125 reduced by 50, so I keep 50, so it's 125 halves. Reduce 40, that means I keep 60. Good. 25, 75 halves. Did I divide wrong? No. Hmm. 0.5. And then I kept 0.6. Oh, I never even applied the point. Oh, wait, no, I did. I did. So it's 125 halves. So, yeah, 3/10 of it. Wait, what percent of the original? It can't be that hard. Unless I'm stupid. It's 37.5. So then why am I getting this wrong? 100 to 125 reduced by 50%. So it's 125 halves. And then later reduced another 40, meaning I keep 60, so it's 3/5 times 125 over 2. 375 tenths. 375 tenths. Um, right, 75 halves. What the heck? I don't know. I'm just gonna go with my second answer. I don't know. It's probably 0.37, so 37.5%. I really am convinced it's that. Okay, let's stop the timer on my phone. And yeah, right at the 10-minute mark too. So we're fine. Yeah. I didn't change anything, so that's fine. So now we're gonna go to round 2, which is algebra 1. Round 2, algebra 1. Okay. And reset and begin. Oh, that's not hard. Okay. 103 metals. The number of silver was 4 more than gold. Bronze was 6 less than gold. And we know that S, well, I did it in the wrong order, but whatever, is equal to 103. So what would it be? G plus 4 plus G minus 6 plus G is 103. So 3G minus 2 is 103. 3G 105. G is 35. So therefore, S is 39. B is 29. So what is it asking? Silver? Oh, 39. All right. Okay, come on. Number 2. The sum of the squares of two consecutive positive odd integers is 202. Find the integers. 911? Yeah, it's 911. That's easy because 81 plus 121 is 202. And I know how you would do that, like actually. It would be, well, let's just call the first one x, so it's x squared plus um x plus 2 squared is 202. Maybe there's a second solution, I just don't know. 2x, I don't think there would be. 2x squared plus 4x plus 4 is 202. Yeah, but it's positive. They say it's positive, so yeah, it's 911. Three lines are in the XY plane, one pair. Oh my God, that looks like a pain. One pair intersects, another pair. If the two lines are perpendicular and have the same x-intercept, that means they have to intersect at the x-intercept. Wait. I'm gonna just draw this briefly. So one pair intersects at -1, 3. Another pair at 8, 6. They're perpendicular, and they have the same x-intercept. God knows where they're actually gonna. So it would be something like this, maybe. And then I don't know how I'm gonna draw a right angle. Probably whatever. Something like this. This is the x-intercept. Then there's another line that intersects at 8, 6. And then at -1, 3. -1, 3. 8, 6. Oh, you know what it might be, actually? It might be something like this. And then it goes through like that. And then -1, 3 and 8, 6. So it might be something like this. I don't know. No, that's not right. Because you know what? That's actually really bad drawing. This is hard. Well, it's not hard. It's just annoyingly. Like, yeah. So then -1, 3, 8, 6. And then it must go like that. So -1, 3. And then this is 8, 6. And then they're perpendicular. Okay. So we'll call this L1, L2, and L3. I want to check the timer so I can see how fast I should go. 5. Okay, we have 5 minutes left. Okay, wait. So L1 is going to be defined by 2 points. So the slope would be, okay, wait, let's just do point slope form. Y minus y1 equals, your slope is going to be 3/9, which is a third, x plus 1. So L1, y equals 1/3 x plus 10/3. That's pretty important to know. But L2 and L3 are the perpendicular. Okay, they have the same x-intercept. So then this will have like m comma 0 because that's where an x-intercept has. And then you find the slopes and when they're perpendicular. Gotcha. Oh, so I don't even need to find the equation. Oh, it's when they're perpendicular. Oh, that's actually smart. So perpendicular means that they're opposite reciprocals. So 0 minus 3 over m plus 1, which is -3 over m plus 1. And what's the other one? It would be 6 over 8 minus m. Oopsies. 6 over 8 minus m. And they have to be opposite reciprocals. So 6 over 8 minus m is the opposite reciprocal, so m plus 1 over 3. Oh, it's going to be a quadratic. Ew. Okay. So wait. 18 is equal to -m squared minus m plus 8m plus 8 m squared minus 7m plus 10 0. So M is 5 and 2. But do they both work? I think they would. I think they would. I'm not going to check. I think they will, though. I'm trying to think of why wouldn't they? Because this would then be a right angle. But who makes sense? It's 2, 0, and 5, 0. I'm just going to go with it. 2, 0, and 5, 0. Okay. Stop. Oh, I didn't stop the clock. Okay. Yeah, we're fine. 8 minutes. Round 3 is, I think that was the parallel lines and polygons. Let me just check. Yeah, parallel lines and polygons. Sorry, my handwriting's horrible there. Ready and begin. Oh, they use GeoGebra. I like that. Find the value of x that causes them to be parallel. Well, they're supplementary. I know that. So oh, I didn't put the 1, 2, and 3. Oopsies. Okay, so 3x x squared is 180. X squared minus, it's really plus 3x minus 180. I'm trying to think of factors. It would be x plus 18. Yeah, that makes sense. 125 and 45 are definitely, or 125. Oh, wait, that's not right. I don't think. Oh, it's not. I didn't multiply right. Where'd I go wrong? It's 15 and 12, isn't it? It is. 15 and 12. Shoot. Real number. Indicator, I'm gonna redo that. It's not that great. Much better. Okay. So it's 12. Not 15. I'm big brain. I am so big brain. It's 12. Yeah, 36 and 140. That's definitely it. The hexagon and the pentagon are regular. Find DCA. That looks like a right angle. It does. I don't think it is. Okay, I'm gonna have to redraw. I'm gonna have to draw this. So 1, 2, 3, 4, 5, 6. And then it's 1. This is 2, 3, 4, 5. This is a triangle. That's a isosceles? Oh wait, no, they're not. And then it extends through like that. Ooh. Oh my God. Jesus. Okay. Um, well, we know that this is 60. This is gonna be an angle chase. 108. Oh, I'm gonna solve this. Okay. Wait. So it'd be 216 plus 60 plus x equals 360 because it's a quadrilateral. 276 plus x, 360. X is equal to 84. So then the supplement has to then be equal to 180 minus 84. 96. Rectangle. Point P is 1 to the right, 1 above. This is a coordinate bash. No, I don't trust putting. Well, I'm gonna put the diagram here. Actually, screw it. This is literally a coordinate bash, or they're hinting at one. Length 4, width 2. So that's 1, 1. WXYZ is inside such that the points are on. There's too many there's too many words. There's way too many words. I don't understand this. ZDY similar to ZAW. How are you supposed to make a parallelogram? When it's inside WX, Y, and YZ has to contain P. Okay, so maybe it's something like this. It's got to. Wow. Okay. Wait, how is that going to be a parallelogram, though? Oh. And the lie... Okay, wait. AB, so this is W. X is on BC. Y and Z, I think. Yeah. YZ has to contain P. Y is on CD. And Z is on DA. Oh, I flipped the parallelogram. Oopsies. So it's actually the opposite way. It is this. And something like that. And then ZDY. What the heck? See, if this were real life, I'd probably almost be done with this wrong because I have to erase and do other stuff and blah blah blah. YZ contains P, ZDY, and ZAW. So this is D, A. This is a right triangle. Oh, these two are gonna be similar. Oh, okay. Interesting. How do we know which parts are actually similar, though? That's the trick. Because if we extended this out and we did that, then this angle would have to equal this angle. But we don't know. Wait, I'm confused. So, oh, wait, it gives you the, oh, okay, you know what? I am really big brain today. Draw, I'm probably already past 10 minutes. Nope, apparently not 7 minutes. So, Z, D, Y, Z, A, W. So, these two are the equal ones. So are these. But we don't know as to where they are. The length is 4, width is 2, 1 unit to the right. But you don't know anything about this. YZ contains, find the perimeter. Is it going to be like the perimeter of the rectangle for some reason? I swear to God, I feel like there's some theorem where it's going to have to be 12. I don't know. There's some stupid trick. I'm telling you. Maybe, wait, what if I do this? Call this X. and then the AZ is 2 minus x. But then how do you, or, well, I wouldn't even call that x anyway, because I already have a point called x. They're parallel, though. And I can't coordinate bash, because I don't know the coordinates of w, x, y, and z, really. All I know is this is 1, 1. So, y is going to be, you don't know. It wouldn't be at 2, 0, because then it would be collinear with A and P. And we can't have it be on point A. So it'd have to be more to the right. And then W would have to be more to the left. And their midpoint has to be 2, 0. Okay. So that shows that if this is like A, this has to then be A. And this is 4 minus A and 4 minus A. And actually, this is not X right here because oh my God, I am actually dumb. X. Okay, so then if this is B, this is also B. This is 2 minus B and 2 minus B. Okay. Yeah, I know it says similar, but it's also congruent as well because the parallelogram kind of like is inscribed in the rectangle. But then what does 1, 1 have to do with any of this? Could I Pythag this somehow? Because we don't know anything about the parallelogram. We don't. Like, we can't figure out anything. We know what D is. We know what... Yeah, I'm just gonna go 12. If nothing can come to my mind, I'll go 12 on that one. But I feel like it's not 12. But... what does 1, 1 have to do with this? Is it an altitude? No, it can't be. It's not. Because then it would have to go through A and P. We know that A squared plus B squared. Oh! What if I tried this? Oh, wait. We don't know if it's a rhombus. That's the problem. We don't. Meaning, like, it's an equilateral, quadrilateral, if you know what I mean. What? I don't. Could I use trig? Maybe. I don't know. P? How do you coordinate bash that? I don't think you can. Huh. 1 to the right, 1 unit above. So what if but we don't know where point Y is. That's the problem. I don't think you can figure this out. There's got to be some ridiculously insane way. There has to be. There's no way that you can do this. It's got to be a rhombus. Is it not? I feel like it's a trick. And it's somehow going to be a rhombus in the end. With sides of 3. I don't know. If it were a rhombus, this would be true. Two A plus B is 5. Um, I feel like there's infinite solutions to this. Wait. Oh, I figure it out. Oh my God. It is so dumb. This is the dumbest thing to exist. Um, the similarity ratio that I totally forgot about. Oh, and you have to set that equal to oh my gosh, come on. Okay. So what you have to do is look at the congruent sides of the triangle. So we know that ZDY is similar to ZAW. So ZD is similar to ZA. So 2 minus B over B equals Z dy over AW, 4 minus A over A. So 2A minus AB equals negative AB plus 4B. So 2A is 4B. A is equal to 2B. But then what does that tell us? That doesn't tell us much. I guess you can like say y is like x comma 0, z is like 0 comma whatever, and then w is gonna have to be like some angle equal. I don't know. The timer is probably ridiculous right now. Yeah, we're way above what we need to be at. I'll just stop it. I know this is just now for just to see. 2A is 4B, so A is 2B. So what does that tell us though? It tells us that that the hypotenuse would have to then be b root 5. So this should be b root 5, b root 5, and then this should be, again, b squared minus 4b plus 4 plus really a squared minus 8a plus 16 is equal to c squared. So this would then be 5b squared minus 20b plus 20. And then we square root it. But somehow, there's a nice way to do this. Somehow, it might be 4 root 5. If b is somehow 1 and a is 2, but a can't be 2. Because if it were 2, then w and y would be perpendicular to the sides. It can't be. What if it is, though? What if? You just like don't know. 5b squared minus 20b plus 20. B is 1 would cancel. That would have been nice, honestly. What if it's a half? 10 minus 5 fourths. This is not going to be a nice number. 45 fourths. 45 over 2 multiplied. This could be anything, though. Like, is it somehow going to be 12? I don't know. But again, does it say simplest form or simplest exact form? Okay. Leicester, whoever made this problem, I hate you so much. And this is why I'm not going to get an 18. Wow. Or I could take the highest of the 5, or the 3 highest of the 5. That's the other possibility. Um, what? There's no way. There is no way. Because we use similarity. We know that this is root 2, but that doesn't, it's not even an altitude necessarily. Or is it? We don't know. We don't know. I feel like they just don't give you enough info for this problem. I really don't think they do. Tan theta is A over B. Um, could I somehow like find ZX? I don't think so. I'm going with the fact that it has to be 12. It's gotta be. It's gotta be. Unless it's either that or 4 root 5. It, I don't know. It's a rectangle. It's not. I don't know. I just feel like it's gonna be a dumb answer. 4 root 5 is actually smaller. But my question is, would the quadrilateral cover up? It would have to cover up more, wouldn't it? Because it's inscribed, and it basically would have to be larger than the sides. Oh, but no, not necessarily. Not necessarily. Oh, wait. Maybe it's less. 4? So then the hypotenuse would. I feel like it's not 12. 4 or 5 might actually be it. I really don't think it's 12. I don't know. This problem is crazy. Okay, we're done. I don't even know. When I see the solution, I'm gonna be so baffled, I'm telling you. Round 4 though. Let's just forget about that. I just made the video so much longer. To be fair, I already had my answer done, so go. What the? What is number 3? Why is a Fibonacci sequence on here? Ugh, I hate those so much. Round 4, third, fourth, and fifth. That means the average has to equal the fourth. 3x 15, so 5. This one's gotta be 13. Yep. So it's really subtract 16. Negative 19. Oh, wait, I didn't even put the... Integers a and b are the two terms of a Fibonacci sequence in which each term after b is the sum of the previous two terms. So the fourth sequence is 42, sixth term is 109. Each term after... What the heck? So it goes A, B, and then the next one after B is the sum of the... So A plus B? A plus 2B, and the fifth term has got to be 2A plus 3B. And then you have 3A plus 5B. So then the fourth term, I feel like I've seen this problem before somewhere. A plus 2B is equal to 42. 3A plus 5B is 109. Maybe it's 20 and 3. No, that would have been close. Trying to think of Diophantine equations. 95, no. 90, no. 85. 17 and 8? Yep, it's that. It is. We'll just make sure. $17. And A is 8. Yep. Try and speed up these last 2 rounds, don't worry. To make up for round 3. The third one, though. 1, 2, 4, 5, 7, 8. So it's basically the first n integers, but now you're getting rid of all multiples of 3. So what? That's so wait. So for every 3 numbers, we have 2 values. Because we just keep getting rid of 3, 6, 9. So for every 3, like 1, 2, 3, you have 1 and 2. 4, 5, 6, you have 4 and 5. 7, 8, 9, you have 7 and 8. So basically, since we have 100 terms, we're really focusing on every number up to 150. So the end goes to 149. So really what we're doing is sum of first 149 natural numbers minus sum of first 49 multiples of 3. Well, we know the sum of the first 149 natural numbers. It's it's this. I want a calculator. This is not. And then, so this is basically sum x equals 1 to 49 of 3x, which is really, well, I'm just going to simplify this slightly. 3 times the sum of the first 49. So it would be 49 times 50 over 2. So this is 149.75 minus 75 times 49, right? Because 50 divided by 2 is 25, times 3 is 75, times 40. That's actually a nice problem. Because now what you can do is factor out a 75, and you get 149 minus 49. So it's 75 times 100. 7,500. Done. Done, 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 done. 7,500. Let's just check number 2 just in case. So what is it? 8, 17, 25. The fourth one is 8, so 30, so 42. That's good. 2a, so 16, 51, 67. Good, that works. And then 3a plus 5b, so 24 plus 85 is 109. That's right. All right, stop the clock. Good, 629. That was good. Okay. I remember last year they had a killer number 3 for round 5. So matrices and systems of equations. God knows if one of these is going to be a matrix. I have to write out the matrix, so I'm going to need a lot more space. Okay, ready and go. Oh my god, okay. Good thing the third one is actually not a... Ooh, I really like number 3. Okay, wait. Oh, okay, wait. So z plus 3 is 43, so z is 40. Now 2m plus 10 is 40. So 2m is 30, so m is 15. And then 15 times 3 is 45, minus 8 is 37. So 37 equals 2x plus 3x is 17. And then you have y equals 85 minus 2 or 83. Solve for the matrix X. It's just the inverse. That's all it is. So it's a negative 1b. Yeah. So it's really, you have to find the, okay. 6, 5. -3, -2, -1, and then multiply it by 9, -6, 12, 3. So it's 1 over the determinant. So -12 plus 15 is 3. And then multiply by -2 and 6. And then we switch the signs on these two. 9, 6, 12, 3. And then I'm pretty sure we could just bring the 1/3 over to the other matrix. So it's really just this. So then we get -2 times 3 is -6 plus -2 times, so it's 4, it's 6. It's -2 times 3 plus 3 times 4, yep. So the top right is -2 times -2, so 4 plus 3 is 7. And then you get -15 plus 24 is 9. And then 10 plus 6 is 16. 6, 7, 9, 16. It's also equivalent for solving this system. This is why I'm taking linear algebra on that, to expertise with inverses and all that stuff. So therefore 6a minus 3c is 9. I think that works. Yeah. Okay, number 3 though. Terminal ordered pairs. You're gonna want to factor this, I feel like. Can I assume they're integers? Why? Oh, I actually did it the other way. Yeah, xy plus y squared, yeah. So then x plus y is 9 over x, and x plus y equals 16 over y. So this means that 9 over x is equal to 16 over y. 16x is equal to 9y. And we'll just solve for y. X equals 9, 16th y. And then we have to actually solve that. Pain in the butt. So um trying to think of what that would be. 144, I think. Yeah, it's 144. Is that a perfect square? Yeah, it is. 225. Wait, so x is 9/16 y. Wait, yeah. Water bottle. And then y. And these are our solutions. Actually. What was it again? 9 fits, 16 fits. Okay. I'm assuming those actually work when I check it, because that's going to be a pain in the butt. Stop. 7:36. That was good. All right, the team round. My favorite. So it's 1 per round and then 4 from whatever round. Okay, and go. Oh no, combo. Why is combo on here? Ugh, this is so bad. This is so bad. Okay, let's just start with 1. There's like no legit geo. It sucks. Wait, so 8/18 minus 1/18, so 7/18. And then something 108. 14. 47 108. How many lattice points are on the line segment joining those 2 points? Three-fourths. So let's just find the equation anyway. Y minus 3/4 plus 3/2 plus 6/2. This is, I can't make the within a set sign. So this shows x needs to be, this is really 18/4. That might actually help. 3x plus 18/4. So it could be 24. So, or 18 plus 3x has to be congruent to 0 mod 4. So x has to be 2. Could you have 28? No. 32? No. 36? Yes. So it's probably this 10, 14, 22, 26, 30. So that gives 8 possible lattice points right there. In an equilateral triangle, a segment is drawn parallel to one side and form a trapezoid with legs with length 4. That's easy. That's just basically, you draw a triangle. That's an amazing equilateral triangle, by the way. Sides of length 6, segment is drawn parallel, so it's like this. 4, 4. Really similar triangles, but I'm not going to do it that way. I don't like similar BS. This is 60. Oh my, I'm so bad at writing with this thing. Come on. 60. So this is 2 root 3. This is also 2. And this is 2. Therefore, this is also 2. So the area is going to be 6 plus 2 times height over 2. 8 root 3. Where if I get that wrong after I say it's easy for rushing, I'll flip. Milo lists the first 100 integers, crosses off every integer divisible by 4 or 5. What is the sum of the remaining integers? Okay, so number left is... Oh, I know how you do it if it's like how many are left. Now I have to actually figure out what are the ones there. So it's gonna be cyclic every 20 or cyclic, whatever you want to say, because that's the LCM of 4 and 5. So basically whatever happens for the first 20 has to happen for the next 20. Oh, okay. So 1, 2, 3, 4. Wow, I can't. My hand hurts anyway. I wish I was a little more ambidextrous. I'm really not. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And it's 4 or 5, so you can have the intersection or you can have the, well, it's really the union. So 4, 5, 8, 10, 12, 15, 16, and that's it. Because 4, 8, 12, 16, 20. And then 5, 10, 15. So you have... Oh, wait, is this going to be like a pattern, maybe? So 6. Okay, wait. So 6, 12, 19, 28, 39. Oh, I'm so dumb. Oh, there's actually an even easier way. You find the sum of all the first 100. So wait, this is even better. So sum of 100 integers is just this, which is actually 5050, because Gauss actually is very smart with that. That's 5050, but then you have to find the sum of the ones that you get rid of. So it's really this. Sum from a equals 1 to 20 of 5a. The sum of b equals 1 to 25 of 4b. Then you have to add these. So add, then subtract. But we would overcount multiples of 20 because hold on. In each sum, in the first one it's multiples of 5, second one's multiples of 4. So you're really adding 20, 40, 60, 80, and 100 twice. So then you have to, it's really just 5050 minus 5 times 50. Some of the first 50 integers. Or it's not 50, it's 20. minus 4 and then we add 20 plus 40 plus 60 plus 80 plus 100, which is really just 300 because it's centered at 60. I think this is right. 5,050 minus 50 times 21, so 1,050, minus 2 times 25, so that's 50. 50 times 26 would have to be 1,030 plus 300. So this gives 4,000. And this gives 730. So it's 3,060 or 3,070. Or wow, I am really bad today. 3,270. That is our answer. 5. Does it want me to do a matrix? I don't know. Probably not. I'm doing it the boring way, aka legit solving it. Maybe you can add them somehow. 9x plus 3y plus 5. No, it's not going to do much, honestly. I think substitution might be the best way to go. In the third equation, we can give this. Z is that. So it's that. Wait, that might not actually be that great. Can I just guess and check? Because I know it's going to be one solution. 5x plus 4y. It's going to be 3 and negative 3, I bet. Which then will give 9, 3, 7. What if this is it? I swear to God if it is. No, it's not. Darn it. I'm gonna have to actually solve this thing. Okay. That's that equation. And then for the other one, oh, there is no nice way to do this. Wow. There's no like nice multiples at all. Oh, and you know why? Because I actually didn't even do this right. That one I did do right, though. That doesn't help me, though. Actually, it makes it a lot worse. And there's no, like, substitution. There's no elimination. Well, there is, but it's, like, really annoying. What if I tried X? Six Z. Oh, my computer's just trying to tell me that I have battery. I just put in the battery quickly. My computer's upside down, so I gotta figure out how I'm gonna do it. There we go. Okay. And the other equation. 3. Wow, there is nothing nice about these equations. Wait, what if I actually did this? And then I subtract them. So x is 2z minus 5. Or z, 16z, 21z. So negative 10, negative 52, so it's a negative 62. So this gives y equals. Oh, was I right earlier when oh, that was x and y that were 3. Huh. 2z minus 5. So it's negative 6. Number 6. How many distinct three-letter words can be created from the letters in WOCOMAL? They literally just thought of this question. Wait, who actually made this one? Oopsies, I don't want to look at the answers on this. Bancroft. I love you, Bancroft. No, I'm kidding, I hate you. So wait, it's a three-letter word. So you have how many options for the first letter? So you have WOCOMAL. So the distinct WOCMA. So you have 6 for the first. Oh, you have to casework this. Oh boy. Okay. You have to casework this because you don't know if you're gonna have a distinct letter or not. Okay, wait. So case 1 is the first letter is not an O. So then we're gonna have. So wait, we have W or frick. WOCMAL. So basically, the first letter can be one of 5 things. Then you have to do subcases because you don't know if the last 2 are going to be O's or if they're going to be distinct. So then 1.1 is going to be last 2 letters are distinct, in which if it's not O, then you have 5 letters left, but then you can do a multiply by 4. So 5 times 4 is 20. And then 1.2 is that the last letters are O's, in which we can do one thing. So for case 1, we have 5 times 20 plus 5 times 1, which is 105. And then case 2 is that the first 2 letters, or no, the first letter is an O. Therefore, wait, yeah, this gives 6 times 5 or 30 options for the last 2 letters. Because you have 6 letters, but you have 2 O's. So if I take one O out, I'm still going to have 6 letters left, just one of each. So, and I don't have to worry about repetition. So really, I'm just picking 6 from, or I'm picking 1 from the 6, and then because that one's going to have to be gone, the next one could be any of 5. So it's 6 times 5. So then you have 135. Evaluate the following expression if x equals 6 and y equals 2. I hate these. Like, when x is this and y is this. I think you're going to simplify this, I swear to God. So I don't know if anyone's noticed, but I am a lot quieter now. I don't know why. So we can cancel out this. Just get the y, and same here, except just an x. And then we can cancel out a few other things. So this gives x minus 3 over xy. So when x is 6 and y is 3, I think it was, or no, y equals 2. So we have 3 over 12 is 1/4. Cool problem. Number 8. There are n concentric circles with radii r1, r2, r3, all the way to rn. Areas a, 2a, 3a, na. Find the smallest value of n where r of n is less than 1% larger than... Wow, okay. So what this problem's really saying, I kind of understand this, is you have a point in space. I'm going to draw a circle around it. And then I have to draw another circle out here. And then you just keep doing this. Concentric just means, yeah, I'm just going to have the same point as the center. So this is really R1. This is R2. This is R3. And the ninth circle has radii Rn. So the areas are A, 2A, 3A, all the way to Na. So let's just denote. I don't know. Okay. This is interesting. So pi R1 squared equals A. So this gives the radius as root A over pi. The second one is going to be pi R2 squared, which is equal to 2A. So this is going to give R2 is the square root of 2A over pi. And I think we can kind of see a pattern here, that for R of n, we're going to get NA over pi. So we need the smallest value of n where R of n, the radius itself, is less than 1% larger. So R of n is greater than R n minus 1 by less than 1%. Therefore, what I think has to happen now is Rn over Rn minus 1. The ratio has to be less than 1%. Wait. Let me see if that makes sense. Yeah, that makes sense, I think. So then we just write it in terms of A. So it would be the square root of, well, that's a horrible square root. Oh, oops, no, I don't want to print. I don't even. So what we wanted, no, did I rotate? Bear with me, there we go. Is not even that big. I'm so picky with my square roots. No, not again. All right, there we go. So the square root, that's better, of NA over pi over n minus 1A over pi And you know what? I'm actually going to condense the square root a little bit. Is less than 1/100th. I think that's what this problem wants me to do. I might be wrong. I'm probably going to be wrong, but yeah. So this is really NA over pi times pi over a n minus 1 is less than 1 over 100 squared, which is going to be 10,000. But I'm not going to write that yet. So a's cancel, pi's cancel. N minus 1 is less than 1 over 10,000. What? Are you kidding me? Is this even right? 10,000 n is less than n minus 1. So 9,000. I feel like it's 9,999, not 10,000. And I'm just taking the flip. So let's just actually do the ratios. Less than 1% of this. Yeah, I'm getting the same thing. What I could do, maybe, is without loss of generality, let a equal 1. No, wait. Maybe it's this. Maybe it's 100. I'm gonna go with 100. That makes more sense. But I don't know. I don't think that's right. Number 9, though. Mr. Smithers comes home from the grocery store, 3 bags, 3 distinct food items, vegetable, pasta, meat, vegetable, meat, pasta, meat. 1 item at random. What's the probability is pick 1 of each? So this is another casework problem. So you can't have a vegetable, wait, you could have vegetable, meat, pasta. You can't have vegetable, pasta, meat because pasta is not even in the second bag. So that's it for vegetables. Then if you have pasta from the first, you could have vegetable, meat. But you can't have pasta, meat, vegetable because there's no vegetables in the third bag. You could have meat, vegetable, pasta, MVP, or you could have meat. Oh, you can't have pasta. So it would be meat, vegetable, pasta. Yeah, because there's no vegetable in the third. So it'd have to be those 3 combos. Oh, my belly's growling. Case 1. Let's call these cases. So for case 1, vegetable, meat, pasta. Case 2, pasta, vegetable, meat, another 220 cents. And then for case 3, meat, vegetable, pasta, 427s. So the probability, 1 of each, is 4 plus 2 plus 2 over 27 plus 8 over 27. I have a stats test tomorrow. It has some probability. I really hope I do well on this because I don't even know if I got that one right. 8 over 27. You know what? I'll gotta get in my phone at the same time. Stop. 36 minutes. Wow, that did not feel like 36 minutes. That really felt a lot quicker. So now we're gonna grade ourselves. Using this red. So we're only looking at answers for now, and then we'll look at solutions to the ones we got wrong, because I don't know what the heck we did. I actually got them all right. Yay. I didn't even try to get those ones right. Okay. I knew it. Do I want to count that, actually? Because I'm like, there's no way it's 4 root 5. And it's 4 root 5. We'll give myself a 3. 6 is questionable. Because I was thinking 12, but I'm like, it's 4 root 5. There's no way it's going to actually be 12. So we're going to, you know what? We'll give it to us. I don't know what I'll do there. I'll think about it. I probably will be on the harsher side there, but that is so funny that my other guess was right. I might give myself like 1 point. I don't know. Yup. Good. If that's the only problem I get wrong, though, I don't. 5. Oh, nope. Last one I got 2 of the 3. I'll probably get myself like 1 point there. And we'll give it. I don't know. I don't know what they do if you get the whole thing wrong. If it's like half credit, you get like half of the matrix, right? I just probably made a stupid arithmetic mistake. Oh my god, what the heck? Whoa, I'm getting a lot of these wrong. What? What the heck? Wow. Did I make a dumb error in every single question? I want to wait. Really? 235. That's multiplied by 5. Wow. I really did not do well. We even got the second one wrong? Wow. Got that one though. That is pathetic for myself. Usually I don't do this bad. I want to look at solutions now because I want to see what they. Yeah, we got all those right. We got all these right. Geo. I'm telling you, it's gonna be they're all root 5 somehow. Let dy equal a. These. That's what I did. I did that. Z. Oh, they did slope. 1/2. Oh my god. Jeez. That's actually really interesting. -19, good. Yeah. What part of the matrix did we do wrong? Yeah. I did both of those solutions. Did I not multiply correctly? 6194. What did we put? Four plus 3 is 7. I'm getting 7. Did I not? Wow. Wow, I didn't put the negative. I didn't see the negative. There's your answer. I didn't see the negative sign. Wow, that is pathetic. You want to know what I'm going to do, actually? For the Geo, I just thought of it. What I'm going to do is, because I put 2 guesses, really the second one was my more accurate one, but what I'm going to do is actually give myself half credit for that one. What would it be, a 4 or a 5? I'm thinking a 4. I shouldn't even be giving myself that, but I'm going to do it anyway. So I get a 15 for that meet. That was not a great meet. The team round's pathetic. Like, I want to see the team round, like, so bad. What did they do for this one? They did the same thing. Yep. Alternately combine. Oh my god. Oh my god. Really? Oh. Okay, wait. What did I? 7, 8? Oh my god. Wait. No, I got that right. 7/18. 30. What? Oh my. You know why I got that one wrong? Because I didn't see the calculate 30%. This is why I got it wrong. So this was technically right, but I have to now calculate. God damn it. I got number 2 wrong? Did I not count it right or something? 3/4. Right. How was it 10? Oh, they're saying that you have to include. See, I was thinking about that, but I feel like you don't like. I don't. I thought they meant like are on like it joining, not including it. Oh, that's dumb. You know what? I got the work right. I counted it. I did not think to count. I'm gonna actually give myself that one. That is actually a little bit unfair. That's actually a fair. Um, I think that's fair to give myself credit. Because they don't specify if those two have to actually be like included. I was thinking like on the line segment, but you don't include the endpoints of the segment. Like they're on it. I feel like that's a technical type of. 8 or 3. It's not hard. 3,000. They did my strategy. Oh, you know why? The 3 and the 0 should be swapped. Wow. Wow. Wrong. Did I really get this one wrong? Oh my god. They did matrices. They did matrices using ref. Just kidding, it's RF. Ref. Oh my. What did they do for this one? Given 7. They did complementary counting. Wow. Oh my god. Wait, so where did I miss cases? Because I must have missed cases. The first letter is not O. So it's 5 and 20. But if the last. And I'd still get it wrong anyway. I don't understand the last one at all. This one does not make sense. What? What? That'd be like a good Amy problem. 1 point. Wow. Wow. Really? I feel like no team got that one. Like, I feel like that's one that like no one got. Like, that is ridiculous. And we got this one. Good. Oh, they did combo casework. I did actual probability, which really parallels itself. Yes, so this is gonna be mine. Okay. Yeah, so I'm gonna give myself a 15. With the 5x9 team, which is honestly pathetic. I'll do meet 3 probably this weekend, maybe, or sometime soon. Because I got a class during my January term for college. Anyways, I hope you guys enjoyed this. Leave a like if you want to see more, and I will see you guys next time.